Hello, my name is Benjamin, and today I'm going to talk about free fall, vertical launch, and horizontal launch. Okay, first, we start with the free fall. A ball falls from the top of a building, and six seconds later, it hits the ground. First, we get the data. We know that the time is 6 seconds. The initial velocity in this case is 0 meters per second because we just let it go from top of the building. And we know that the gravity is 9.8 meters per second square. So first, we want to get the height of the building. To get this, the formula is the height of the building equals 1/2 times gravity times time squared. In this case, we don't need to include the initial velocity because it is 0. But if it was a number other than 0, we will have to include it here. Now, we know that the gravity is 9.8 and the time is 6. So we just substitute the information in the formula and we get that the height of the building is 176.4 meters. Now that we know the height of the building, we can get the final velocity. The formula for final velocity is final velocity squared equals initial velocity squared plus 2 times gravity times height. We substitute the information. In this case, the initial velocity is 0, the gravity is 9.8, and the height is 176.4. We substitute everything. We get the square root to be able to get the final velocity only. And we get that the final velocity will be 58.8 meters per second. The next type of problem will be vertical launch. A body is thrown vertically upwards with an initial velocity of 80 meters per second. We first get the data. In this case, the gravity is negative 9.8 meters per second squared. It is because when you throw something vertically up, the gravity starts to pull it down. So it would affect negatively to the operation. The final velocity in this case is 0 because when it comes back to the starting point, it will have a velocity of 0 meters per second. And we know that the initial velocity is 80 meters per second because of the information given to us. Now, what is the maximum height reach? In this case, the formula of height will be initial velocity times time plus 1/2 gravity times time squared. Now we substitute the information. The initial velocity is 80. The time is 8.16 plus 1/2. The gravity in this case is negative 9.8 times 8.16 squared. And if you use the calculator to get it all this together, we know that the height will be 326.53 meters. I forgot to write meters, but it is meters. But first we have to get the time because in the formula we see that time is an important variable for this formula. We get the time with this other formula. Time equals final velocity minus initial velocity over gravity. Now we substitute the information. The final velocity is 0. The initial velocity is 80, but because it is minus the initial velocity, it will be 0 minus 80 over the gravity, that is negative 9.8. And we'll get that the time is 8.16, and that's how we get this number. And now the next problem will be with the horizontal launch. This one is longer than the others, but it's still kind of easy if you know all the formulas. A ball is thrown horizontally from the top of a building with a speed of 8.0 meters per second, and it hits the ground 30 meters from the base of the building. First, as always, we get the data, the initial velocity of x, will be 8 meters per second. In this case, the gravity will be positive 9.8 meters per second square. The initial velocity of y will be 0 meters per second. We know that the distance of x in the x-axis is 30 meters. And with this information, we can get the time. We get time by dividing the distance in the x-axis over the velocity of x. And we know that 30 over 8 equals 3.75 seconds. And now that's all the information we can have for now. If we want to know the height of the building, we need this formula. It's the height of the building equals the initial velocity in the y-axis times the time plus 1/2 gravity times the time squared. We substitute the information, and since the initial velocity in the y-axis is 0, we can eliminate this from the operation for now, and we will have the 1/2 times 9.8 times 3.75 squared. And if we use our calculator, we know that we have that the height of the building is 68.90 meters. Now with this information, we can get the horizontal and vertical components of the speed at the moment when it hits the ground. This means that we will get the final velocity in x. To get it, we know that the formula is the final velocity of x equals the distance in the x-axis over the time. In this case, it will be the final velocity equals 30 over 3.75, which will be 8 meters per second. In this case, we can see that the final velocity of x and the initial velocity of x is the same. It is usually the same, almost always the same, the velocity of x. Now, to get the final velocity of y, we know that the formula is the final velocity of y square equals the initial velocity of y squared plus 2 times the gravity times the height. Now we substitute the information. The final velocity of y squared equals 0 squared, which will be 0, plus 2 times 9.8 times 16.90. We get this number from the previous formula. We use the calculator to get the number, which will be 1350.44, but we still have the square in the final velocity of y, so we just get the square roots, and we get the final velocity of y equals 36.74 meters per second. This will be all the problems. Thanks for your attention.